Okay, I'll try to keep this short. Again, we're still on that Sage thing. I'm just trying to introduce you to using Sage. Um, as you do the problems, though, I want to say you really shouldn't be using Sage to do the problems, but you should start to expand your universe and say, well, maybe I'll try to use Sage to reinforce that Sage can do things. All right. So let me go to the back to my terminal. And again, you can do this online at the sagemath.org site and go to CoCalc. So reset. And we've done sums before, and this is sum. This is 2 star I minus 1 for I in. I know it's transparent, but really it's blurred, right? So it starts at 1 and it goes off to 190. Now we've done this by hand. It's an easy sum to do by hand. Now by hand, I'm not saying you would do 1, 2, 3, 4, 5 up to 190, but it's not a bad sum to do if you understand this is arithmetic and we have ways to do arithmetic sums. All right. The next one is a geometric sum. And I get a little tired, so I'm just going to copy paste. And this is one we've done, or at least I hope you've done. Well, that's a crazy looking number, isn't it? So what do? I approximate that number. All right. I want to go back over the notes. And these are the homework. Yes, you're expected to do that. I'm going to do number 9. All right. Again, I'm just playing around with Sage. I'm trying to learn it, but these things need to be done by hand. All right. So I'm going to say sum. That's going to be minus 3 raised to a power n minus 1. I'm going to use the letter n minus 1 for n in, what is it in? It starts at 0 and it goes to 15. And what do you get? Well, you get the number we're giving you over here. Let's say you want to approximate the number. Dot n, parentheses, it's going to approximate it. What do you get? The number, actually it's writing in scientific notation. That e to the 6 means 10 times, I'm sorry, times 10 to the 6th power. So you'd move this thing 6 places over. We get the same number we get over here. All right, let's keep going backwards. And I don't know, maybe I'll do this one over here. So for, I'm sorry, I didn't mean to say that. Sum, that's 12 star 2 divided by 3 raised to a power I minus 1. Let's see, I minus 1 for I in 1. Whoops, sorry about that. 1 dot 10. What do you get? You get the number you get over here. All right, I want to play around with this one now. And the reason is I want to see what happens when I get to bigger and bigger numbers. All right, so I'm gonna do that. And someone says, I wonder what a big number would be. Let's say you just went to 1,000. But I want to approximate it. I don't want something like that looks like a ratio of integers. And wow, look at that, 36. You see that? And 1,000 is not that big, by the way. Let's say you went to like, I don't know, 100. Well, 36. What are we basically saying there? We're saying is that as n gets larger, this thing gets closer and closer to 36. All right, so what I want to do is I want to go to Wolfram Alpha. Give me a second to do so. And I want to type in the infinite sum. And again, we're just playing around with software. That's all we're doing. So I'm going to say sum 12 times 2/3 raised to the power I minus 1. Let's see, for I equals 1, 2. Well, I could do 1 to 10. Let's see what happens there. The one thing I like about Wolfram Alpha, by the way, it's actually going to typeset it for me. And what does it give me the answer I'm getting over there? I want to try this one though. And what does it say? It says start at 1, but don't go to 10, go to infinity. Well, instead of putting 10 there, I'm going to put infinity. Let's see what happens. One, I want to see, does it typeset it? It does, and it gives me the answer to be 36, right? A fairly trivial problem, right? Fairly trivial problem. The more you play around with this, whether it's Sage or Wolfram Alpha, or if you have commercial software, that's ones I haven't mentioned, the more familiar you become the ability of software to do problems. All right, thank you.